All right, so in section 9.1, we look at the situation where we want to compare two groups. And this is a really common situation. You think about uh, one of the most common designs that we have in statistical research, and that is the experiment, right? Where you have a control group and you have a treatment group, and you do something to the treatment group, and then you measure something and you compare the two groups. And the real question you have, there's two questions you have. Is the first one is, are the groups different? Are the results different from the two groups? And so let me give you a real simple example here. Um, so let's suppose we are looking in 9.1, we're going to compare two proportions. So we're going to look at group A. They followed, we're talking about stopping smoking here, and they followed one particular plan, that a program to stop smoking. And from that group, 51 out of 198 stopped smoking. 51 out of 198. So that gives us a proportion of, if we round to 3 decimal places, 258. So basically 25%. Now this is it. We're going to call this group, we called it group A, but let's call it group 1. So we're going to erase this out of here. I'm going to call it group 1. And that way, we'll call this P hat sub 1. So that's the proportion of people that quit smoking from group 1, following the plan that they followed. When we look at group 2, the numbers are 30 out of 199. And so we'll call that P2 hat. So 30 divided by 199, so that's 0.151, so 15%. So right now what we've got is we got two groups, and we got proportions from two groups. And so what we want to ask ourselves, we want to do some analysis. The first thing is we want to know, are these two numbers different? Now, remember, we would expect these two numbers, these two proportions, to be different just due to different samples. Okay, so there's going to be some natural variability. And they're going to be one's going to be higher, one's going to be lower. But what we're looking for is they should still be, if neither of these plans is better than the other, then both of these proportions should be still about the same. Okay, they should still be about the same, at least in the ballpark. And so the question we want to answer now is, are these differences? Are they different? Is the difference between these statistically significant? In other words, is the difference big enough for us to say group 1, their plan worked better? So we're doing a hypothesis test, okay? And so if we start writing down the hypotheses for this particular test, it's going to look, it's going to have a lot of the same things that that we've seen before. We have a null hypothesis, and the null hypothesis is that the proportion of people that quit smoking from plan 1 equals the proportion of people that quit smoking from plan 2. Now, if you look closely, that is the same as saying this: P1 minus P2 equals 0. So we'll often refer to the equals 0 model. Okay? The null hypothesis is that there is no difference between the two plans. The alternative hypothesis, okay, or the, let me try that again, the H sub 1, is that there is a difference, all right? Now, we're in the same boat as we were before. Sometimes we think P1 is going to be higher, sometimes we think it's going to be lower, sometimes we're going to think they are just not equal. But what we'll always try to do is set it up so that we have the one being greater than the other. Okay, and we can always write it that way. So we think that group 1 works better, quit smoking at a higher percent than group 2. And of course that is the same as saying P1 minus P2 is greater than 0. All right. So that's going to be our null and alternative hypothesis. All right. So the first thing we're going to do is we need to figure out a few statistics for us to analyze. So the statistics we need, let's put them in blue. We want P bar. Okay, so what this is this the total number of people all together in both groups that quit. So in other words, it's going to be 81 out of what? 397. So that gives us 0.204. So that's what P has. P bar is it's just the total number of people that that quit smoking. And then we need Q bar, and Q bar is 1 minus P bar, and it is, as it has always been, 0.796. All right, so we're going to need those going forward. All right, what we need is the difference that we actually found is this. We found for our difference in our sample when I did P1 hat minus P2 hat. So I actually take the difference between the two things. 0.258 minus 0.151 0.107. All right, and so that's the actual difference. There was a 10% difference between the two groups. We want to keep track of that, and what we're trying to determine is this significantly different than the hypothesized difference of 0? Sure seems like it, but remember, we need to do some analysis on this. So the way this works is just like it always has. The claim is that the difference between the two groups is 0, and so that goes right there, right? Our sample lives up here at 0.107, and so we need to find the area to the right of that, and in this case the area will be the p-value because this is a one-tailed test. So I just need to find that area. How do we do it? We need the z-score. Now here we have a different thing. Okay, we have a formula for the z-score that maybe we haven't seen before, and so we want to keep track of this. So you use this z-score when you're comparing two proportions. All right, that's what you need to remember when you're comparing two proportions. Here it is. It's kind of ugly. So the z-score is equal to P1 hat minus P2 hat. We've seen those before. Minus P sub 1 minus P sub 2. Now notice that, remember the difference. When I put a hat on these things, that means that's the proportion that comes from my sample. Without a hat, these are the proportions from the population, which we don't know. But that goes on top of our formula, and here is the bottom of the formula. Square root of P bar, Q bar over N1, the sample size of group 1, plus P bar, Q bar over sample size of group 2. And there's our P bar and our Q bar that we calculated before. So in this case, when I fill in everything in my formula, it's going to look like this. P1, I'll write it up here. We already know what P1 hat minus P2 hat is, right? That is, let's do it in blue. That is 0.107 minus, now the next part is the P1 minus P2. Now here's the nice thing. Look right here. P1 minus P2 is hypothesized to be 0. So, and that will most often be the case. So that, at least that part is easy. Now the bottom is kind of a mess. It's going to be 0.204 times 0.796 over 198 plus 0.204 times 0.796 over 199. And that's what we need to calculate. That is the z-score for here, which we can then use to find the area. All right, so when I run that through my calculator, I get a z-score of 2.64, right? So that's the boundary. So what is this area? Right here, well, I look in my table, 2.64. 2.64 gives me 0.9959. That, of course, is this area, 0.9959. So that means this area is 0.0041. Oops, that's right there, 0.0041. So that is our p-value. So we need that p-value. We would compare it to the alpha compare it to the alpha level. And let's use a 0.01 significance level here. So let's let alpha equal 0.01, right? So clearly 0.0041 is less than 0.01. So that, just like always, tells us we will reject the null hypothesis, which is that they are the same. So it appears that we found evidence that the proportion of people that quit smoking between these two groups is going to be greater in group 1.